Okay, shall we maximize? Good afternoon. Are you back from your break? Did you have a nice break? All right. Okay, we're talking about all the entities that were involved in the usage of HP. Sorry. So we talked about the hardware provider and their responsibilities. We talked about the cloud provider. We mentioned the system admins, and then now we also have users. The users are in that graph. They are usually the most porous because all users can't have the same level of prowess. They can't all be experts. You can't entrust security to users. Even if you do have a session of capacity building and teach them what to do and what not to do while they are logged onto the system or while they are using the system, you still can't trust that they will function at the capacity as an admin. You understand? So you have to tie up all the loose ends by yourself as an admin. Approaches to HPC security. Some of the realities of an HPC system. We talked about this briefly in some other aspects, but conventional firewalls and antivirus solutions will not work. And they will not work because you want to ensure that all of the computational power that you have for your nodes are reserved for actually doing computation, not just something like running an antivirus or running a firewall. And if you picture the way a cluster works, sometimes you have massive amounts of data flowing through the system. For instance, I've seen this in movies, and I want to believe that it applies in real life. I'm not sure. But if you have an airport system where you have a set of people that are banned from going to other countries, maybe their passports are seized, and you have facial recognition software. But imagine all the people that you have to compare that data against. So you need an HPC system to, in real time, compare all the facial profiles of everybody that is passing through with what you have in your database. Now, obviously, you want all the power you can get. Then at that point in time, you don't want to think about having to deal with a firewall such that you only have 50% of the ability of that cluster. So oftentimes, you're not going to be using a firewall at the level of the node. You can gate your networks. You can ensure that before traffic leaves your center, it is properly firewalled, and only all the ports and protocols that are accepted are being used. But at the level of the node, you can't put a firewall on your nodes. Compute systems can be compromised at the kernel or processor level. Bad actors often take advantage of vulnerabilities in systems that have not been patched or upgraded. Like we've discussed before you went for a break, you need to be on top of patching your systems. When providers release these kernels and these CPUs, they regularly release patches and upgrades to ensure that these devices function at the best of the best. And they know that people are always working to see their vulnerabilities. Something that didn't look like a vulnerability in the first instance can be something that someone rides on to have access into your system. We talked about the case of Equifax, a public-facing website. Now, the mistake they made over there was that they didn't patch. They didn't patch. But assuming that they ensured that their cluster was in a segmented system, there's something you call a DMZ. The fact that the hackers are able to get access to their data center is because they didn't do proper segmentation of the networks. Now, so you have to be on top of all of your systems to ensure that they are properly patched. The way hackers can get access to your system and then reach into other parts of your platform is by riding on top or leveraging on vulnerabilities that have existed on those platforms before. For instance, if I told you before, Cisco released a set of routers to a client, and while they were getting to the client, somebody intercepted them and installed a patch in each of those routers. Now, when they got to the client's place, he had the confidence that he bought these devices from Cisco and he installed everything. So security, like I said, must start from the supply chain. But also, you must also always patch your devices. Now, when your device provider sends you those devices, they're going to be at the state at which they were manufactured. They are going to be exactly at the state at which they were manufactured. And hackers know this. And they will keep probing your systems. They'll keep trying to see if there's a vulnerability. So the only people who can get above these are the people that continuously patch their systems and ensure that they are always at the most secure level of the operating system or the central processing units. So let's talk a little bit about how to secure systems in the HPC fashion. One of the most important ones is that you have to put your clusters in a demilitarized zone. That is, a demilitarized zone is a zone where all the nodes can talk to each other without fear of being compromised. Without fear of being compromised. But for that to happen, that network has to be put in a certain level of accessibility. The people that can connect to it are limited. So, okay. Another one. From this, okay. No, from current slide. All right. So you have to segregate your systems. You have to ensure that there is no public access to your clusters. And the way that is done is such a way that you employ routers, switches, and devices that know how to isolate a network. That know how to isolate a network. When this happens, what you realize is that all the nodes in that network can communicate with one another without fear of being compromised, without fear of losing compute resources. Data must also be encrypted at rest. And then what you start to think about, because most of the solutions that provide encryption in storage solutions, some of them work at the software level. Some of them work at the operating system level. But if it works at the operating system level, it's not recommended because it also uses RAM from your node. You understand? Now, if you understand the way nodes are often connected to storage solutions, depending on your configuration, each of those nodes need access to the storage so that you can push data that has been computed or processed into the storage solutions. Now, when that happens, data that you just finished working with needs to be encrypted. Now, when you are selecting storage solutions, you ensure that the storage solutions you select are the ones that provide encryption on board. If you're going for a NAS, ensure that it has onboard solutions that facilitate encryption without involving the operating system that it's going to be connected to. Otherwise, that will also introduce problems for the operating system that is going to be connected to it. That way, because systems can be breached from multiple levels, if somebody were to have access to your data, as long as it's encrypted, they can do nothing with it. We're not going to assume that our system is impenetrable. We've seen that a lot of big organizations who have all the money and all the resources to secure their systems still have breaches. Now, so our saving grace is that we must ensure that our data is always encrypted where it matters the most. And usually that's when you're finished computing your results and it's being stored. You also need to monitor the logs constantly to detect irregularities in traffic. HPC traffic is usually recognizable. Most of the things we do inside of an HPC are peculiar. Unlike your system where today you browse, tomorrow you play game, you don't know what is happening. You see traffic, you start thinking, what did I do? But in an HPC system, the things that you do are so specific, so you can minimize intrusions by just looking at the traffic logs. What came from where? When you was talking about Kubernetes yesterday. You install containers for a specific purpose. So you can identify if they are doing something other than what they are configured to do. You already know the path. Yes, an anomaly, something that is irregular. If your HPC system is supposed to run simulations, and part of that simulation has a container or a node that is supposed to talk to another node, it's configured, it can't change. So if you look at your traffic logs and you see that this node is accessing a node that it shouldn't access, then you start to think, what's happening? That is the best way to ensure that your system is integral. You need to constantly look at the logs. A lot of people don't understand that the logs are important. And Linux has a lot of logs. A lot of logs at the logging level, at the root level, at the kernel level. There are logs and logs all over the place. And that's because it's a text-based system. But it ensures that when you look at these logs, you can identify things that are irregular. It is much more forensic to look at things that are irregular than to sit down and just ensure that when something happens, then I'll go and look at the logs and see how it happened. So you can be proactive by looking at the logs. There are software sniffs and that can help you look at the logs to analyze if something is irregular. You can train it. This is a question of using systems that are optimized by AI. You can train it to always ensure that data flows in a particular direction, that behavior is consistent in a particular way. And if anything happens that is not supposed to happen, it throws a flag, it alerts you. Yes. And then you can look at it and see if this is something that should be allowed in the system. If it's not supposed to be allowed, then you can shut it down. That's a way to be proactive about the communications that your system has. The sincerity of this is that if anything is going to come and compromise the system, it's mostly going to come externally from the networks. If something is happening that shouldn't happen, if you trace the logs, you can see where somebody altered code or maybe altered your kernel code such that whenever you boot your system, something funny that isn't supposed to run will run. So by constantly monitoring the logs, You can be on top of things that can ensure that your system is always shipshape. I'm not saying this is 100% perfect, but this can get you on the way to ensuring that your system is always, yeah. And somebody will be thinking that this is a lot of work for a system administrator, you know, but these are all the things you need to do to ensure that, because I don't know if you've ever had to deal with a disaster recovery situation, especially whether you have backups in place or not, but on that scale where big data is involved, it's almost impossible. So it's better to go through the rigors of ensuring that the system is constantly monitored rather than react to an intrusion. I expect that this one is optimal, and as system administrators is something that we should know. But a lot of people don't do it because it increases the expense, capital-wise. Because if you are preparing backup solutions for data at that scale, you know what it means. Yes, you're going to be backing up in petabytes and zettabytes. But as administrators, one thing they will tell you is that you have to prepare for the day that you'll be hacked. Don't look at it as something impossible, but something inevitable. So when you are configuring your systems, configure it with a sense of mind that how am I going to react should this inevitable happen? And whenever an event occurs, it changes the way an administrator thinks. It's happened to Yahoo. It's happened to Facebook. It's happened to big hotels. It's happened to airports. It's happened to military organizations, hospitals, like you said, even defense contractors who have secrets that nobody should see. So you have to prepare for the inevitable. Ensure you back up. Most of the times it's redundant, but you have to prepare for it. Yes, you never know. You just have to prepare for it. And those are the things that make intrusions less of a problem. If you are hacked, if your data is encrypted, if you're constantly monitoring the logs, to get back in shape, it's just going to be a matter of time, not something impossible. You can't prevent people sniffing at you. For instance, if you put a web server in there, that information is going to be public. So you want people to go there and look at it. But it's a catch-22. What I mean is that good people will go there, bad people will go there. Bad people will try to figure out how to use your installation as a gateway to other things that they are not supposed to reach. And if you are not on top of things, they will find information that they are not supposed to find. One of the best ways of ensuring that you secure your systems, especially those externally facing systems, is trying to make sure that systems announce themselves. Web servers announce their names, their IP addresses. A lot of people try to obfuscate. Like if you're using an Nginx server, you say I'm something else. If there are places where you announce your IP address, you change it up so that even if anybody sees it and it's not encrypted, they won't have a full picture of how your internal systems work. Now, that is golden in the sense that no matter how secure or how firewalled your system is, if they have an idea of how the inside is, that is one step, that's one leg into your systems. Yeah. Conclusion. It's a very brief one, and I hoped we were going to be able to get into practicals before, but we can't. Yeah. For reasons I can't get into right now. But if we're supposed to get into practicals, there's so many applications we can look into. We have so many providers. Practicals at the level of say, Google is different from practicals at the level of Amazon. For on-premise applications, designing software firewalls or even using hardware firewalls is specific to that provider. Do you understand? So if you want to design practicals, it has to be something that ideally works for you. If I come here with a firewall that you're not going to ever use, if there was time and we're able to ask ourselves questions, what are the softwares or firewalls we should look at? You know, maybe we'll have talked about that. But like I said, every administrator with a small Google search, you can learn about the device you are using. There are popular firewalls in place, but your administration, your organization will buy something specific. You learn about that particular firewall and how to use it, and how to apply some of the principles we've learned. So whatever practicals we were to do will be specific to those devices, which is, I don't like doing something that is too specific. But security is a dynamic concept in the sense that if we were to learn about security yesterday, what we'll be talking about today is going to be different. And security is a minefield. A lot of people like to tell you that there are solutions that you can just quickly use that will solve all your problems, but that's not true. Even the experts, the people who have masters, who are professors, they have ways of improving themselves because these hackers don't have academic qualifications. They just know how to sit down and keep doing something and keep doing it until they succeed. What they want is a piece of the pie you have, something that is profitable, and they will sell it to anybody. So what is profitable to them? A piece of your data, a piece of your intellectual property, your resources. I'm yet to find one hacker who has his own data center. Yes, they will happily borrow yours. So that's something you should keep in mind. Security is a fluid concept. There are people who have all the degrees and all the diplomas, but what they knew or what they know is something they taught them yesterday. If you're familiar with certifications, they usually have upgrades, right? If you do Cisco, you have to go for the upgrade because maybe the router they taught you with is different. That's the way security is. So I'll adjourn you as an administrator to keep getting yourself in the know. That's the only way to rise above any challenge that may come upon you. Any questions?
Okay. Hello.
Hi.
Good morning. Yeah. Thank you for your presentation.
Okay.
I want to come back to the main components of the HPC.
Okay.
During the presentation, I don't know why you putting the securing of electricity.
Securing of
electricity.
electricity.
Yes, current or voltage. Because electricity is really important to work everything around HPC.
You're right.
Okay.
Power is an essential component for on-premise situations. But I wouldn't say power doesn't factor into security. You understand? But most ICT professionals don't do power by themselves. They usually they're accompanied by electricians or people who handle these things. You understand? So it's just like the situation that I talked about, firewalls. Your installation is different from my installation. And this thing also differs from country to country. If you're talking about voltage, in some countries they use 110. In Nigeria they use 220. You understand? So this is a very different concept that is handled differently from place to place. Does that answer your question? No? Okay, please give it to him.
He's not satisfied.
I think he wants to shed some light on the question. Want to ask more questions?
Uh,
Or is it something different you want to talk about?
It's not very different because I want to talk be beyond security of electricity security,
Okay.
the physical infrastructure security, that sheer voltage is not that. See, and the upper higher voltage and fire because
Fire.
it can produce fire
Yeah.
which compromise
Compromise your
infrastructure
installations.
security.
That's safety.
There
at
are
that point of level.
flood,
Okay.
there are someone who can intrude to
So you are trying to say sometimes if somebody has access to your installations, maybe overclock your operating system, which can cause fire. Is that what you're trying to say? Something like that. Okay.
And I have a question.
Okay, go ahead.
I already know DMZ, and I see you have talked about science DMZ, and I wanted
To elaborate.
to know
To go
the
deeper in
difference
DMZ.
and what is science DMZ, because we implement DMZ ordinary, but it is the first time I
Okay.
have.
Okay. Let me answer his question first. We talked about power. Yeah. At the level of your cluster, if someone were to gain access to your systems, because I want to believe that you're not talking about power alone, because yes, you can have fire damage to CPU resources, just as much as you can have fire to any kind of resource. But if you're talking about fire that is instigated by malicious access, we've seen cases where people gain access of your system and overclock your CPU. And they have so much access that they reach your kernel, they stop your fan, right? And they overclock, and this creates overeating, eventually fire, and things like that. But at the core level, the fact is that someone overpowered your system. You understand? We can talk about all kinds of damage that can happen when somebody has overpowered your system. Let's talk about medical research, for instance. If someone is packaging or researching doses for cancer, or even say as little as COVID, and someone gains access to your system discreetly. Now, you know that it's not all kinds of intrusion that is overt. Sometimes in espionage world, the kind of hacking that happens is such that they go in there, they change data in such a way that it will benefit them. And you would not even know about, if the hacker is very good, you might not even know he's coming to your system and done something. Let's say it changes the dose, but because some of your research is driven by by data, and you make decisions based on data, and you do not know when data has changed, you think you are still working with the right data, someone gets dead. You understand? So a lot of things can happen. It depends on the specifics of the situation. We've seen cases where people do insider trading. That's usually one of the reasons for corporate espionage. They get into your system to figure out what is happening, and they use that information to purchase or not purchase stock. Now, a lot of hacking on the surface may look as if it's innocuous, harmless. But it depends on what the hacker wants you to know or not. There are senior hackers and there are junior hackers. So if someone were to get into your system and you don't know about it, you happily think you are secure. But if someone gets into your system and deletes a file and things are not working, then you know, oh, something is wrong. Because it's glaring that somebody came and there was a repercussion or a reaction because of what they did. But hacking is not always like that. That's why it's very important to monitor traffic. Sometimes hacking in such a way that you won't even know. Now, all of the intrusions we talked about, sometimes is often when people see a hacker selling something on the dark web. That was when they knew that Facebook data was compromised. They didn't even know that they were compromised. It is when they were compromised that they went and did what you call postmortem to figure out how the data got out of there. And in most cases, that is how it's going to be. If the hacker is any good, you're not even going to know that they came into your system. Not all hackers want to destroy you. They want to make it such a way that they take a bit today, they back away. Next tomorrow, they take a bit. And that is the most dangerous hacking, because it only comes in to retrieve the information that you think is confidential to you. So you must be on top of your toes. Figuring out that somebody is in your system is very important. It's not all intrusions that make noise. Some of them are so innocuous or innocuous looking that you think that you are still. And to your second question, sorry, if I can recall. Your second question. Okay, DMZ. Right. A DMZ is theoretically, it's just a zone where it's secure and devices can connect to each other without fear of being compromised. Most of the time, routers and switches provide ability to create a DMZ. It's not something you do physically by yourself. You use your router or your switch. Do you understand? It's about connecting where data can go or who has access to this data. But when you put your nodes that are in a cluster in a DMZ, it ensures that each of those nodes can connect to themselves, but people can connect from outside. They will probably be on a different virtual LAN, have a different set of IP addresses. They might be on the same switch, but they won't be visible to each other. Now, there's a trend that is going on. A lot of people use IoT devices. IoT devices are also controlled from most HPC environments or the public cloud. And when people put their devices on Wi-Fi or Bluetooth mode, they don't know that their information is going out. Like, I have some of my switches on IoT. And I do that because there's a particular time I want my lights to come on, in the morning and at night. But behind the scenes, data goes to the cloud that says, switch off, switch on. Somebody who's particularly smart just needs to study that data to know that this is his behavior. You understand? And they know the perfect time to get into that system because you're already connected. Yeah. So it has happened a lot with IoT systems in such a way that people get cracked, people get hacked. So now they recommend that when you want to put your systems on the internet so that they can be enabled with IoT, put them in a DMZ. Your routers can help you configure a DMZ. And if you're very good with using things like Cisco switches, you can also do that as well. So you put those devices in a different sub-network, a network that only specific congregation can access them. That way, even if a hacker were to access your IoT device, it can't get access into your other systems. He may be able to see what you want him to see only. So a DMZ essentially isolates your network. And you ensure that nobody has access to it except the devices you want to see each other. And you can go a step further and you can use MAC filters. Who knows about MAC filters? You can use MAC filters to the extent that if you're not satisfied with DMZs, you can use MAC filters and ensure that a device that talks to each other must approve. I want to talk to this guy. That way, you're sure. Yes, there's MAC, you can spoof the MAC address. Yeah, but someone who goes to that level is someone who's truly a genius. Yes, and then there's little you can there's little you can do. All right.
But I wanted to know the difference between a DMZ and a science DMZ.
Yeah.
Yes.
So I don't know the difference between a DMZ and a science DMZ. You can inform us.
Okay, no, it is the first time, because I've seen On your presentation,
Okay.
you talk about science DMZ.
Okay.
Uh,
See,
I suppose it is a high level of DMZ,
no,
but I don't
it's not
know.
a high level of DMV.
Okay.
It's not, but science DMCs were first used in HPC systems, traditional HPC systems. Do you understand? But when I read that documentation a long time ago, I assumed it was the same thing. Do you understand? So when you said it's different, I felt, oh, I can learn something today. You understand? Because here, like I was saying, we're all learning. We're all learning. I can't profess to say I know everything about security. There are archaic configurations of security I don't know. And there are things that are being installed or initiated today in the world of security that I don't know yet until I get home and I read it up. Or in practice.
Okay. Thank you.
You're welcome.
Thank you. I'll
You want to talk about science DMZ?
no. About the power thing he was talking about. I had an understanding from what he was saying that it's not only when we say security now, I was thinking from to my mind what he was trying to say is that it's not only when we say our data is secured, it's not only hackers and all that that can constitute risk to our data. I think that's why I was pointing out maybe power, maybe this thing. And then it leads to now my own question. I'm wondering, back then, just like you said, what security was yesterday definitely is what it is. It's not what it is today, maybe it's not what it's going to be tomorrow. It's dynamic. So back then, they used to talk about social engineering when they are talking about security. I don't know where it is now. If you have any updates or if you have any lights you want to throw in that regard. I don't know if you understand me.
Yeah, I understand you, but I don't have too much expertise on social engineering. But to the best of my knowledge, social engineering is very close to catfishing. It's about getting people's identities and representing them as yours. You understand? But to his question about electricity, our scope is a bit limited. Do you understand? There are levels where you just have to trust that everybody will do their job right. In Russia, there were a couple of people that in a facility, they were administrators like yourself. They were mining Bitcoin with the facility that was put in their care. And they were caught and they were arrested. And some will sell information to the highest bidder. You understand? So, but these are people. You can say, trust the people you work with. But I believe there's nothing you can really do about that. How do you know what people will do? Yeah, it's a problem. But how do you know what people will do? Yeah. That's a problem that you cannot mitigate. That's why, for instance, if a terrorist gets into a plane and then hijacks it, despite all of the analysis and all of the preventive measures that they take, it's a human problem. There's no solution to human problems. Even if someone that is well-thinking, who is in the best of his mental processes, and all of a sudden has a breakdown, he can do certain things, you know. So there's no solution to the human problem yet. The only thing you can do when people misbehave is remove them from the picture.
Okay. I think sometimes making people aware and conscious too might help.
Making them aware that.
This problem exists, just as you have mentioned it.
Okay, okay. No, okay. You are system administrators, right?
Yes.
And what you're talking about depends on your morality. Do you get? It depends on your morality. What we say about your morality, I'm sure everybody knows that it's the principles of being true to your contract, because when you're employed, you have a contract. Do you get? Now, if you go ahead and do something that you're not supposed to do, there's no prevention to that. I'm not going to tell you, don't do this, because we are talking about security of your systems. Do you get? You are the administrator. Now, if you decide to go and sell information or use the resources for something else, me telling you not to do it, I'm sure you know that you shouldn't do that.
Are not even aware what those kind of things can be used for. Maybe some time back, I had an account where people played with passwords. You are given a password, you give someone, it happens around here, please go and do this for me.
Okay.
And they are carrying your passwords. You don't know what such people can do with.
Like, if, for instance, you give someone your ATM card and say, this is my PIN, go and get me some money, Abi?
Yes.
You don't know whether he could go behind you and use the same. Well, that is security at some level, but it's not specific to HPC, if you understand what I mean.
Yeah, but we have persons working there too who could be careless.
Okay.
Yes, that's what I'm
Okay.
trying to say. So maybe it's more of a mind thing for everybody.
All right. Let me formally add this one in. She raised a very good point. The people that we work with, morality is also involved in this. Although you can't determine what people can do, it is essential that you are aware that people can sometimes behave in an unparticular way. I think in some institutions, the way they handle this is they have employment contracts, they have security policies that say don't do this. But that doesn't help because, sincerely speaking, this is morality. If you're an administrator and someone has done research in your center, research that is super costly, and I don't know what you're being paid per month, and you have somebody who has approached you and says, I'll give you several millions for this. And you think about it and you say, oh, it's more profitable for me to get this money and go away. Do you understand? I don't know if there's any cure for that. There's no cure for that. The best you can do is trust that you do your due diligence in hiring the best people. Because if that center belonged to you, you're not an employee, you wouldn't do that. You understand? So, but that's another level. That's not specific. If you are dishonest at the level of the security of the HPC, you can be dishonest at any other level. So that's beyond, that's what I mean when I say it's beyond HPC. Maybe it's an HR problem. Okay, please go ahead.
Okay, what I want to ask is that looking at the PDU, the power display unit, there is a way you can monitor it remotely. How do you protect against someone hacking that and shutting down your HPC system?
Well, I think that if someone already has access to your PDU, they're already inside of your system. I think the solution is just to prevent access at all. If you have the appropriate firewalls in place, if you have the appropriate monitorings in place, you can prevent things like that. But to be sincere, if someone has better skills than you and has something ahead of you, they can gain access to any part of your system. But if that happens and you are monitoring, the best is recover from that quickly. And then you know what not to do or what port not to open. Some of these things are peculiar to your industry, and sometimes it's going to be peculiar to your installation. It hasn't happened to anybody at all. If things that happen to people were generic, it would be easy to figure out security. But sometimes when it happens to you, you are the first, or it's so unique that the only thing you can do is learn from it. Yes. And then you know what not to do to put yourself in that situation anymore. Well, I think it's a very interesting question you asked, and it's something that has been discussed. Supply chain needs to be monitored, because once you leave the manufacturers, it can be compromised at any point, even when it's sitting in your center. If a user comes in that is compromised, he says, I want to use your system, but he has a different objective. And then while you're not looking, he puts something in your CPU. Or it copies code to the kernel space. What are you going to do? It's logging. You're asking a lot of questions that are interestingly about the capability of a human being. You're not spiritual, you can't see a lot of things. But you can keep monitoring. You understand? And I've seen that, you've seen that done a lot in movies, where somebody walks into your establishment, puts a router. Even though you air gap your entire system, if somebody were to put a router here, it sends information away. Or somebody just walks in, takes one CPU, air gap, that's ensure that traffic doesn't travel beyond that organization. Or if I say you air gap this, that means it doesn't have capability to access any other network except itself. So you remove the routers, or in this case, you remove maybe the Wi-Fi device, adapters, and things like that. No USB slots, nothing. So it's only going to work with the information you put in there, just alone. But it's not realistic, because you often want it to communicate so that that information will work somewhere else.
Mentioned about antivirus as it relates to HPC system. I want to ask, is there any import of antivirus to HPC system?
Okay, I was saying that you can put an antivirus on your nodes, but it'll steal away your compute. It'll take part of your processing power, because it's running. Antiviruses are most of the waste the most precious resources on your system ever, because what it does is waiting for the time there will be an intrusion. If there's no intrusion, it just sits there chopping memory. But you can't do that for HPCs, because you have to do it at the level of a node, because each node has its own processing system, its own CPU, its own RAM. You understand? So the best you can do is protect communication from the inside. You understand? Then, if you think about it, the data that usually comes to clusters is very large. The data that is ingested is very large. And antiviruses, by nature, like to scan every little thing. So you see situations where your system is clocked to 100%. In that scenario, it's doing nothing but trying to scan, and it's doing no work. Any more questions or contributions? All right, sir. I think he needs the mic.
in the slide how to secure HPC system. You said that we have to put the compute node behind the GMZ. It's can we let the logging node and the
Sorry,
storage,
can we get?
can we let the logging node and the storage node in DMZ and let the compute node behind?
Okay, if I get you clearly, you're saying that can we put the login node and
Yeah.
sorry, login node
And storage node.
and storage node outside of the DMZ? Is that what
No,
you mean?
no, in the DMZ.
No, in that typical scenario, the login node can't be in the DMZ because you want it to be public facing.
Yeah.
You understand? In that scenario, you configure that login node to have specific access
By the
to the DMZ.
Okay.
Do you understand? Yes,
Can
but you have special ports that you can access. Maybe port 80, and then you can have that login node itself can be firewalled because it's not doing any compute. All it does is authentication and authorization.
I don't understand.
No, it doesn't have to be in the DMZ because then people won't have access to it. Well, your storage is in your storage solution, your NAS. Whether it's in DMZ or not, it's still in a device. Do you get? Yes. So it can be handled physically because we talked about personnel. You understand? If people have access to your system, your location, they can just grab your device. Yes, that's a security risk. So if the data is encrypted, well, that's okay. They have the device, but they can't do anything with it. And if you've backed up your resources, you should have a copy of it somewhere. Your question? Yeah.
It is a contribution.
Okay.
In fact, generally, it is the firewall, the node behind the
Not
firewall,
behind the- yeah.
and it is the firewall which is front of the DMZ, because we set some rules
Yes.
access to the
Yes.
network.
Sorry? Yes, please.
Uh,
Can you draw,
to-
right?
I-
Yes,
I-
go ahead. Oh, please go ahead.
But I have some picture here. If
Okay,
you can
if you
see,
can,
it is a network.
yeah, if
Yes.
Engineer D, no, not you. He wants to project something.
Or project through.
Okay, let's see whether he
Project?
answers your question. yeah.
Okay.
The only way you can project is to join the Zoom. Do you have Zoom on your system?
Zoom. Yes. Okay. Okay. Okay.
Okay. Do you have the marker? Okay. 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 Okay.
Maybe it is the same firewall. Yes, the incoming traffic and the outgoing.
Okay.
Firewall. My question is.
So there are people that are online.
Maybe these two firewall are the same firewall. I put it here for having more
Clarity.
yeah.
Okay.
Yeah, it is for the incoming traffic and outgoing, or the other sense. If the traffic is from the internet to the enterprise. My question is, have I if I have to put the logging node here and the and the storage node here,
Okay.
and to put the compute node that they will because they will
The HPC
do
itself.
the job
Okay.
uh, in my local network.
Yeah. Okay.
Or yeah, my question is that, or have I or if or my job is to let the logging node here and to put the storage and the compute node here. What's the main?
Okay. The DMZ is a subnetwork.
Yeah.
It's a kind of network in itself. So your enterprise, your
Will-
HPC will typically be in that network.
Yeah.
You understand?
Yeah.
So it's not a filter. This will be in here. You
Yeah.
understand? Then the login node will be out here.
Out here. Yeah.
I'm sorry. Can we draw? Can we do it better? Can we clean?
You have it on your
Are you projecting it? Go ahead.
I think you understand my question.
Yes, I
Yeah.
understand your question. Sorry? Why is it not showing? Yeah, he's already drawn it, but can we?
But I think it's better to wipe.
Yeah, to wipe. No, I'm not writing, but I don't know whether I can.
To wipe.
Can we also put this? I'm done. Oh, it's in French.
You manage.
Where is it?
What is DMZ? It is a V zone.
Okay.
V zone, which behind the firewall,
Okay.
we are not in the DMZ because we have set some rules in the firewall, and
Okay.
then after the firewall, it is the DMZ. It is like a zone of confiance. Come on, Lee.
After the switch, you mean?
Voila. Yeah.
After the switch?
No, after the firewall, because there are some rules set on the firewall.
Okay.
And if you want to enter in the network, you have to present or to
So
authenticate, or some. There are some rules when you are restricted.
Okay.
Well, yes. Then after the firewall, there is the DMZ, because the Cisco has a IP, a public IP, the video conference IP. We can get it easily.
Okay.
But if you want to enter in the network, then you have some rules.
Okay.
Some of the public address are behind the firewall.
The firewall. Okay.
Example, it is we can consider that mail bobo is a node. It is a webmail server. NFS, it is a NFS server. You know, but
this one, like this NFS server has multiple
multiple network
interface,
and
one of them is
address.
public, right? Is what you're trying
Yes.
to say? Okay.
And it is an example. It can take and take that an example. If it is not.
Yeah.
It doesn't know DMZ and what it is. Why?
Was he
Why an
following?
example?
He's just trying to give an example.
Yeah,
of the
I know.
DMZ.
Were you following? Did you see what he was saying? You didn't look. Okay, let me see a summary of what he was saying. So this is a firewall, right? Are you listening? This is a firewall. This is the internet. This is typically your access devices. Now, these are, let's assume this is the HPC, right? This is a DMZ. Now, what was wrong with your picture the other time is that you assumed the DMZ was like a filter. Do you understand that? Yes, I said put them after the DMZ, but it's just a manner of saying. The DMZ is a zone where you put everything in that DMZ as a similar network address. It's not the public address. You understand? They can talk to each other, but things from outside that zone can't talk to them, except for configurations like this, where you have multiple interfaces. Yeah, multiple interfaces, and then the router knows how to switch, how to access this from outside. Yes.
We can call in a faith zone. It is an exchange zone.
A what?
An
Exchange zone, okay.
It's like in front of your house. In front of your house, you have your door, which is secure. And after the door, you interact with others. Then you secure what you have. You have to have. Then your door and inside your door. But you are obliged to do something to interact with some, and you have some public address, and it is what we call demilitarized zone. There is no weapon there. But what is about you must maximize the security, then someone can enter inside without some rules. Then I represent this zone Okay.
Thank you so much. Yeah. Yes.
In my head,
Sorry, it's a manner of speaking. It's
yeah,
a manner
is
of
the co-
speaking. It's
is
just
the
a manner of
not
speaking. Yeah.
is not. Yeah. No.
Behind the zone.
Yeah.
Yeah.
Yeah. I do understand. For me, there is there is a difference between node and compute node. When I read compute node, I think about the node in their functionality.
Okay.
Compute
Okay.
node,
Okay.
logging
Okay.
node, and so
Okay.
and so
Okay.
forth.
Sorry about that.
Yeah. It's
Yeah.
just not. It's just not. Yeah, I do understand. Yeah. You know, here you put the compute node behind. I think this is only pin compute node. Yeah, yeah. But only compute. There is logging and yeah.
You just mentioned it as well.
Yeah.
Talking from the perspective of the whole high performance computing system, because you have compute node, login node. So he was thinking you are just being specific only on compute. Yeah.
But I think the most important thing is that it's a virtual LAN, and the people that have access to that LAN are limited. Do you get? That's the take home. They're limited. And then in some installations, you can also configure it in such a way that if you want to be really strict, that communication goes in one direction. Communication goes in one direction. You understand? So, and you can do it all the way to the protocol level, TCP IP. It depends on how good you are at the networking layer. Yeah. Well, I think the most important thing to know is that once you put nodes in that zone, anybody who tries to hack you after they've gained malicious entry cannot proceed beyond just the surface of where they've hacked. Yeah, you can share. Thank you so much. Yeah. Any more questions or contributions? You have one? Sorry? Yeah, good. Yeah. All right. Okay. If there are no more questions or contributions, I think we've come to the end of this presentation. Thank you for listening.
So on behalf of the organizing committee, we want to say a big thank you to Mr. Ola from WordPress. Thank you.